Okay, so we're going to go through an example of how to find an antiderivative or to solve a differential equation by using what is called separation of variables. So let's talk about what a differential equation is. So this equation right here is a differential equation because it contains a derivative, right? It has that dy dx. That's what lets me know that it is a differential equation because it has some sort of a derivative relationship. So it contains a dy dx or a derivative, okay, which we know because we see the dy dx there, okay? But now the next thing is what makes it different? What makes it different from this equation? So looking at those two, what makes it different? And think about it maybe in terms of like an antiderivative. If I had dy dx equals 4 over x to the third, and I asked you to find the antiderivative, I could rewrite this as 4x to the negative third. And then when I integrate that, or take my antiderivative, I'm going to get 4x to the negative 2 over negative 2 plus c, which is also negative 2 over x squared plus c. So if it has just an x in there, you guys already know how to find that antiderivative. But the next question is, what the heck do I do when I have an x and a y on the same side of the equation? Okay, so here are your very generic steps. We're going to go more in detail into what these mean. But the first thing we have to do is separate. The next thing we're going to do is integrate. We're still going to solve for our unknown value c. And then our last step is always going to be to write it in y equals. So let's go through an example. Here are your steps, okay, with a little bit more detail that I'm going to follow as I go through. So step 1, you want to separate the variables, and I give you some little hints on how to do that. Step 2, we want to take the antiderivative. Step 3, we want to solve for our constant. And step 4, we're going to write it into y equals. Okay, so I'm going to flash back and forth between these steps as we're going through our first example. Okay. So what do I mean by separate the variables? So we want to get our dy's, everything that has a y on one side and everything that has the x on the other side. So consider the differential equation dy dx equals negative x over y. Then it says find y equals f of x. So this means put it in y equals at the end. Okay, it has to be in the form of y equals. And we want to find the particular solution, and we'll talk about what that means in a second, using the initial condition, of 0, negative 3. Okay, so that's your x and that's your y. Okay, so it has to satisfy that initial condition. So let's follow our steps. Our first step is going to be, I'm going to go and number them, is we want to separate the variables. So I want to get the things that have the y's on the same side and then the things that have the x's on the same side. So let's rewrite this. I'm going to put the negative up with the x just so it has somewhere to go. If you put it down with the y, that would work also. So the first thing I'm going to do is I'm going to multiply both sides by dx. So that's going to give me dy is negative x over y times dx. Okay, so it canceled out on the left, brought it over to the right. Okay, now the next thing, I got to get rid of the y and move it over to the other side. So since the y is dividing, I'm going to multiply both sides by y, and I get this. Okay, so that's our first step. We separated our variables. You're going to have to use some manipulation. Sometimes you might have to, never add or subtract. Sometimes you might have to multiply or divide, and sometimes you might need to factor, okay? But you never, ever, 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 ever want to add or subtract a variable. That's just not going to work here, okay? And avoid moving constants to the y side. We like to keep constants on the x side. as much as possible, which we don't have any constants here yet. Okay? All right, step 2. We need to take the antiderivative of both sides. So antiderivative, I'm going to use integral notation. So if I do the integral of y dy equals the integral of negative x dx, okay? Now when I take the antiderivative, I'm going to add 1 to the exponent, divide by my new exponent. Add 1 to the exponent, divide by my new exponent. Now we have to do a plus c here, but I'm only going to put the plus c on the right side because technically a constant is a constant, and if I had it on the left and I had it on the right and I moved them over to the same side, it's still just going to be a constant, okay? Okay, so now the next thing I'm going to do actually before I go any further is I'm going to just try and simplify this a tiny bit. I don't like those 2's in the denominator, so I'm going to multiply everything by 2. And that's going to give me y squared is negative x squared. Now a constant, if I multiply a constant by 2, it's still going to be just a constant. So no matter what operation you do to your c value, it's always just going to stay as c, okay? Because when we go to solve it in the end, it's going to give us that actual value, okay? So there we go. We did step 2 where we took the antiderivative of both sides. Now, step 3, we want to solve for the constant. So all we're going to do is fill in the given point to solve for c. Unless we have natural logs are involved, then we're going to take a little bit of a different route, and we're going to solve for y first. But since this one's pretty straightforward, I'm going to go and I'm just going to plug in my x value and my y value. So I know that it's going to be negative 3 squared is negative 0 squared plus c. So 9 is 0 plus c. So my c value is just going to be 9. Okay? Nothing too crazy so far. Now our last step is we want to go back and take our original equation. So I'm actually going to go down here a little bit lower. I'm going to go here. And I'm going to say, all right, I have y squared is negative x squared plus 9, because I know that my c value is 9. And I have to solve it for y. So I'm going to square root both sides. Oops. So when I square root y, I'm just going to get, when I square root y squared, I'm just going to get y. And when I square root the right side, remember we always have to put a plus or minus sign in front of that square root, okay? Now this is where this word comes in handy. Okay, particular solution means I want the solution that is particular to this specific problem, okay? Now, this specific problem, I know that I have this ordered pair 0, negative 3, right? So since my y value is negative, right, then I only want this negative part of this solution, okay? So the particular solution to this problem is going to be the negative square root of negative x squared plus 9. So it's very important that whenever you get that plus or minus sign, you always go back, analyze what your initial condition was, and decide, do I want the positive one or do I want the negative one? So that is going to be the steps to doing that differential equation. All right, one more example. So let's consider this differential equation. We have dy over dx equals 6y squared times x, and we want to find y equals f of x, so this means it must be in y equals at the end. Okay. The particular solution, so we're going to have to make sure that it's specific to this problem, and we have the initial condition y of 1 equals 1 over 25. So let's take step 1. We want to separate our variables and get everything that has an x on one side and everything that has a y on the other side. So the first thing I'm going to do is bring that dx over to the other side. dy is 6y squared x dx. Okay. Now, I'm going to bring the y over to the other side, but what I'm actually going to do, that 6 is not attached to that y squared, okay? Everything that's over with the y sometimes gets a little bit more complicated. So if you have a constant here, I'm going to leave that constant and just move the y squared because it's just going to make our lives a little bit easier when we go and find our antiderivatives. So I have dy over y squared equals 6x dx, okay? Just for the sake of clarifying a little bit, I'm going to pull that dy out to the side, just so that it looks a little bit more, pretty for you guys. Okay, so we got it all separated. Second step, we have to integrate. So 1 over y squared dy, and then the integral of 6x dx. So we know this one's actually pretty easy, the 6x. So let's work over here. I know that this is actually the integral of y to the negative 2. Okay, so now that I have it all written better, let's take our antiderivative. So I'm going to add 1 to the exponent, divide by my new exponent, add 1 to the exponent, divide by my new exponent. And don't forget your plus c. Okay, let's make it a little prettier. I'm going to pull this y to the negative 1 down to the denominator, and I'm actually going to pull my negative sign out in front. Okay, and then let's go and plug in our initial condition. Okay, if you wanted to manipulate this around a little bit before you plug in your initial condition, that's okay. Sometimes I like to refrain from doing that just so we don't make any tiny little errors in our manipulation as we go through, but you can, okay? So let's plug in our y value. So be careful here. This y is 1 over 25, so it's really negative 1 over 1 over 25 equals 3 times 1 squared plus c. Okay, negative 1 over 1 over 25 is really just negative 25. Okay, and then I'm going to subtract 3, so I get c equals negative 28. Okay. All right, last step. I'm going to go back and say I have negative 1 over y equals 3x squared minus 28. Okay, so my last step now, I have to make sure that this gets into y equals. So what I'm going to do here is, because I don't want to multiply by y, because that's going to bring that over to the other side. I want to leave the y on the left-hand side. So what I'm actually going to do is just do the reciprocal of both sides. So I can flip this around and make it negative y equals 1 over 3x squared minus 28, right? And then the last thing I need to do is get that negative away. So I'm just going to divide by negative 1, which is the same as multiplying by negative 1. So I'm left with y equals negative 1 over 3x squared minus 28. Okay, now keep in mind there are some variations of this. If you had 1 over negative 3x squared plus 28, that is the exact same thing. I just moved that negative down to the denominator and distributed it. If I put the negative out in front, that's the same thing as well. Okay, so sometimes when you go to check your answers might look a little bit different, but they can still be equivalent forms.